How many ways can you implement a singleton in Java? Let me show you something interesting. We can create a singleton in 5 approaches, but only 2 are correct. Now here is the reality. 90% of developers write option 2 and it is completely wrong. And in interviews, only 2 answers are actually considered as a strong. So in this video, I will walk you through the all 5 approaches, which ones are broken, which ones are correct, and which one you should confidently give in an interview. Before jumping into code, let's understand the problem. Why do we even need singleton? Imagine database connection, configuration service, or cache. Do you really want multiple instances of these? No, right? Because it creates inconsistency, wastes resources, breaks system behavior. So the goal is simple. Only one instance in the JVM and it should globally access it. So the first implementation is eager initialization. So we have used static fields. We already know static fields are static members are belongs to class. And this is thread safe because JVM guarantees static initialization. But there is a problem. Instance is created at class load time, even if you never use it. So if this is expensive, you are wasting memory and resources. So now the second implementation is lazy initialization. The most developer choose this implementation. So here we are checking instance is null. If not, we are creating the object, right? So this looks correct. And in single threaded code, it works perfectly. But in multi-threading, it breaks. Now if you see here, two threads accessing your code, 2 threads can enter at the same time and both pass the null check and both creates the object. So singleton guarantee broken. So never use this in production because it is not thread safe. So the third approach is synchronized method. We have already seen in the previous using lazy initialization, we have a problem with multi-threading. So 2 threads are creating the instance. Now using synchronized method, we can guarantee that one object will create. We already know synchronization will allow only one thread at a time. It will log this method and other threads will wait. Now this code looks perfect, right? Only one thread enters at a time. But think about this. After instance is created at the first attempt, do we still need synchronization? Because if you see here, every time it will log the method and other threads will wait. Even if you create a object in first attempt, every time we are doing locking. So that's unnecessary overhead. In high traffic systems, this becomes a performance issue. Now the fourth implementation is double check the locking. Now observe this carefully. We check twice. Here we are checking 2 times. First check no lock and which is fast. Second check inside the lock. So here we are using synchronized here. The piece of code block we are applying the synchronized and which is safe. So only first creation uses lock. After that no locking. This is perfect balance, which is thread safe, high performance. But if you see here, we have used volatile keyword. This is a critical keyword. Without volatile, this is still broken because JVM can reorder instructions. We already know about the volatile keyword, right? So volatile keyword always write directly to the main memory. Whatever the changes, it writes to the main memory so that other threads can see the changes. So here we have used volatile keyword. So the volatile prevents this, guarantees visibility, prevents reordering. This is the correct and advanced answer. So this is the best way to implement the singleton. And this is the final and best approach, which is enum based. Because JVM guarantees one instance, thread safety, serialization safety, reflection safety, no extra code needed. So this is the answer that impresses interviewers immediately. Now here is something most people miss. Singleton introduces a global state. Only one object get created and it will shade across the application. This creates a problem in testing. So this is why Spring does something smarter. Spring creates one instance but injects it. No static calls, easy to mock, testable. So in production, prefer Spring Singleton scope. Avoid static singleton pattern. And in real systems, prefer dependency injection over static singleton. If you understand this deeply, you are not just writing singleton, you understand concurrency and JVM behavior. Tell me in the comments which singleton implementation have you used in real projects. Thanks for watching GK TechVerse. Subscribe and keep upgrading your skills. See you in the next video.